Hello, in this lecture we will find the radius of the small circle. In the drawing we have a quarter circle, and inside the quarter circle we have angle BCD that equals to 90 degrees, chord CD equals to 2 units, OD equals to 3 units. And inside the quarter circle we have also a small circle, and we want to find out the radius of this small circle. Okay, so first of all we will define the center of the small circle as point P. This is point P, and we will join together points P and A by a straight line. So actually AP will be the radius of the small circle. I will define AP as small r, the radius of the small circle, and we will join also points B and P together by a straight line. And we will define the touching point between CB and the small circle as X, and then we will join points P and X by a straight line. Actually PX is the radius of the small circle. I will define it as R, that is the radius of the small circle, and we will also define angle ABP, this angle, as theta, and actually tangents theta equals to AP over AB. Okay, again, tangent theta equals to AP over AB. But what is AP? AP is the radius of the small circle, so we can substitute AP by small r. So tangent theta equals to small r over AB. Tangent theta equals to small r over AB, and if we multiply this equality by AB, we will get that the radius of the small circle equals to AB times tangent theta. Okay, so actually in order to find out the radius of this small circle, we must find the size of AB and the value of tangent theta, and after it we will multiply one by each. We'll multiply them by each other, and we will get the radius of this small circle. Okay, so first of all I will draw again triangles ABP and triangle BPX. Okay, so actually we have triangle AB This is PB. And this is point B. This is point A. Okay, so I draw again triangles ABP and PBX. Okay, those are triangles ABP and triangle PBX. Okay, so we will focus on those two triangles. Triangle PBX and triangle APB. On those two triangles, actually we found out that AP is the radius and PX is also the radius. So AP equals to R and PX also equals to R. Okay, so here we can write down that AP equals to PX, and both those two are the radiuses. They are equal both to R, so they are equal to each other. AP equals to PX equals to R. Okay, and also we know that PB is a common side because it belongs both to triangle APB, and PB also, side PB also belongs to triangle PBX. So AP equals to AP, or PB equals to PB. It is a common side. PB equals to PB. It is a common side. Okay, PB equals to PB. I'll write it again. PB equals to PB. This is a common side. PB equals to PB, it is a common side. And also we know that AB equals to BX. AB of triangle APB equals to BX. That is of triangle PBX. AB equals to BX. Again, AB equals to BX according to two tangents theorem. Actually, two tangents theorem states that the lengths of two tangents from common external point to the circle, to a circle, are equal. So I will read two tangents theorem again. The tangent theorem states that the lengths of two tangents from a common external point to a circle are equal. Okay? So here we have two tangents. AB is tangent to the small circle at point A, and BX is also tangent to the circle at point X. So those two tangents exiting from the same point, that is same common point, that is point B, and they are tangent to the circle. AB is tangent at point A and BX is tangent to the circle at point X. So according to two tangents theorem, those two lengths AB and BX are equal to each other, or AB is the same length as BX, or AB equals to BX. Okay, so we actually proved that all the sides of triangle PBX are congruent to all the sides of triangle APB. All the sides of triangle ABP are congruent to all the sides of triangle PBX. Therefore, we actually proved that a triangle ABP is congruent to triangle PBX. Okay, we proved the triangle ABP is congruent to triangle PBX according to side rule. Actually, side rule states that if you prove that all three sides of one triangle are congruent to all the three sides of the other triangle, then those two triangles are congruent to each other according to side rule. Okay? Therefore, from the fact that triangle ABP is congruent to triangle PBX, we can derive that angle ABP that equals to theta equals to angle PBX of the other triangle, and both those two angles are equal to theta. Again, from the fact that triangle ABP is congruent to triangle PBX, we can derive that angle ABP of triangle ABP is equal to angle PBX of triangle PBX, and both those two angles are equal to theta. Okay, so actually angle PBX, this angle, is also equal to theta according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, angle ABP equals to angle PBX, and both those two angles are equal to theta. Okay, so in the next step we will extend line segment CB and line segment DO until they intersect, or until they touch each other, or until they intersect. And we will call to the intersection point between line segment CB and line segment DO E. Okay, point E is the intersection point between CB and DO. Okay, actually angle, we know that angle DCE equals to 90 degrees. It is given us in the question. Actually angle DCA is a peripheral angle. This angle is DCA is a peripheral angle that equals to 90 degrees. Again, angle DCA is a peripheral angle that equals to 90 degrees. And we have a rule that states that any peripheral angle that equals to 90 degrees must rest on the diameter of a circle. I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees must rest on the diameter of a circle. So, and we know that a peripheral angle DCE that equals to 90 degrees rests on DE. Therefore, according to the rule that I state, we can derive from the rule that I mentioned that angle DCA that rests on DE rests on the diameter of the circle. So DE is the diameter of the quarter circle. Okay, DE is the diameter of the quarter circle. Again, from the rule that I stated, we can conclude that DE is the diameter of the circle because of the fact that the peripheral angle DCA rests on DE, and the rule that I states that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle, and peripheral angle DCA that equals to 90 degrees rests on DE. Therefore, DE must be the diameter of the quarter circle. Okay? So, DE is the diameter of the quarter circle. Therefore, DE equals to 2R, and because of the fact that this is a quarter circle, DO must be the radius of the quarter circle, so it equals to capital R, and we know that DE equals to 2R because it is the diameter of the quarter circle. So if DE equals to 2R and DO equals to R, then OE must be equal to R, and R equals to 3 units. So OE equals to DO equals to R equals to 3 units. Okay? And we will create from the quarter circle a semicircle. Okay. Again, because of the fact that we have been given a quarter of the circle, angle DOA must be equal to 90 degrees. Because of the fact that this is a quarter circle, this angle must be equal to 90 degrees, and we also we know that DE is the diameter of the semicircle and also of the quarter circle. Therefore, DE is a straight line. Okay, as the diameter of the semicircle, it is a straight line. Okay, DE is a straight line. And we have a rule that states that the sum of the angles in a straight line is equal to 180 degrees. The sum of the angles on a straight line is equal to 180 degrees. Okay, I will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees, and we know that DE is a straight line, so the sum of the angles at any point on DE must be equal to 180 degrees. So if we focus at point E on the straight line DE, the sum of the angles must be equal to 180 degrees. So at point O, we have this angle that is a right angle, that it equals to 90 degrees, plus angle EOB, so the sum of those two angles must be equal to 180 degrees according to the rule that I presented to you. 90 degrees plus the size of angle EOB must be equal to 180 degrees, and if we subtract 90 degrees from this equality, we will get that angle EOB equals to 180 degrees minus 90 degrees is 90 degrees. So angle EOB equals to 90 degrees, or this angle EOB equals to 90 degrees. It is a right angle. And before that, we know we have also another rule that states that vertex angles are equal to each other. Okay, vertex angles are equal to each other. Again, the rule states that vertex angles are equal to each other. So actually here angles ABC, this angle and angle EBO are two vertex angles. Okay, so and according to the rule that I mentioned, they must be equal to each other. So angle ABC must be equal to angle EBO, because those two angles are vertex angles. Okay, according to this rule, the vertex angles are equal to each other. Angles ABC and angle EBD are two vertex angles, therefore they are equal to each other. And what is the size of angle ABC? Angle ABC equals to theta plus theta, that is to say it equals to 2 theta. So if angle ABC equals to theta, then angle EBO must be also equal to 2 theta. Okay, so angle EBO must be also equal to 2 theta. Okay, and in the right triangle EBO, in the right triangle EBO, the sum of the angles are equal to 180 degrees, but we know that angle EOB, this angle is a right angle, it equals to 90 degrees, so the sum of those two angles must be also equal to 90 degrees in order to complete the sum of the angles in triangle EBO to 180 degrees. So angle OEB plus angle OBE must be equal to 90 degrees in order to complete the sum of the angles in triangle EBO to 180 degrees. But what is the size of angle OBE? Angle OBE equals to 2 theta, so we can substitute angle OBE by 2 theta equals to 90 degrees. So angle OEB plus 2 theta equals to 90 degrees. So if we subtract 2 theta from this equality, we will get that angle OEB equals to 90 degrees minus 2 theta. And again, angle OEB equals to 90 degrees minus 2 theta. This angle equals to 90 degrees minus 2 theta. Okay, and we know that the sum of the angles in any triangle, and especially in triangle CDE, must be equal to 180 degrees. So in triangle CDE, the big triangle CDE, that is also a right triangle, we know that the sum of the angles is equal to 180 degrees. That is to say, the size of angle CDE plus 90 degrees, the size of this angle that is 90 degrees, plus the size of this angle that is 90 degrees minus theta, 90 degrees minus 2 theta, must be equal to 180 degrees. Okay, again, this equality states that the sum of the angles in triangle CDE equals to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees, and so we have 180 degrees on this side of the equality, and we have 180 degrees on the other side of the equality. So 180 degrees will be cancelled, and what is left is that angle CDE angle CDE minus 2 theta equals to 0, and if we add 2 theta to this equality, we will get that the size of angle CDE is actually 2 theta. Okay, the size of angle CDE here, this angle equals to 2 theta. Okay, and we will continue to focus on triangle CDE. So on triangle CDE, we know that tangents 2 theta equals to CE over CD. But before that, we will implement the Pythagorean theorem on the right triangle, triangle CDE. According to the Pythagorean theorem, the square of the hypotenuse, that is actually DE square, equals to the sum of the squares of the perpendiculars, that is CD square plus CE square. So CD square plus CE square must be equal to DE square, that is according to the Pythagorean theorem. Okay, on the right triangle, triangle CDE, according to the Pythagorean theorem, CD square plus CE square equals to DE square. But what is the size of CD? CD equals to 2, so it is given us in the question, so CD square is 2 square, 2 square is 4, plus CE square equals to DE square. What is the size of DE? DE is 2 times the radius. 2 times the radius is 3, so 2 times the radius is 6. So DE equals to 6, so DE square will be equal to 6 squared, that is 36. So we found out that 4 plus CE square equals to 36. Here we will subtract 4 from this equality, and we will get that CE square equals to 36 minus 4 is 32. Okay, here we will take a root out of this equality, and we will get that CE equals to root of 32. Okay, CE equals to root of 32. We know that 32 is 16 times 2. And the root of 16 is 4. So in total, we will get that CE equals to 4 times root 2. Okay, CE equals to 4 times root 2. Now we know that in triangle CDE, tangents 2 theta equals to CE over CD. Again, in the big triangle, the big right triangle CDE, tangents 2 theta equals to CE over CD. But we know, we have already found out that CE equals to 4 times root 2 and CD equals to 2 units. It is given us in the question. So we will get that CE equals to 4 times root 2 and CD is 2. So we got that CE equals to 4 times root 2 over 2. 4 over 2 is 2. So in total we got that tangents 2 theta equals to 2 times root 2. Okay? Tangents 2 theta equals to 2 times root 2. And we want to find out the radius of the small circle, and we know that the radius of the small circle equals to AB times tangents theta. Okay? So we must find the value of tangents theta in order to find out the radius of the small circle. So in order to find out the value of tangents theta, I will present you a new trigonometric identity that states that the value of tangents 2 theta is actually equals to 2 tangents theta over 1 minus tangents square theta. Okay, so we will use this trigonometric identity in order to find out the value of tangents theta. Okay, because we have already know that tangents 2 theta equals to 2 times root 2. So we can write here tangents 2 theta equals to 2 times root 2. So actually 2 times root 2 equals to 2 tangents theta over 1 minus tangents square theta. Okay? Okay, so here I substituted tangents 2 theta by 2 times root 2 and we got this equality. Here we will define tangents theta as x, and then we will solve a quadratic equation. So tangents theta will be defined as x, tangents theta equals to x. So here I will substitute tangents theta by x in this equality. So 2 times root 2 equals to 2 times tangents theta. Tangents theta is x, so it is 2 times x over 1 minus tangents theta. Tangents theta square is x squared. So in total we got that 2 times root 2 equals to 2x over 1 minus x squared. So if we cross multiply this expression by 1 minus x squared, we will get that 2 times root 2 1 minus x squared equals to 2x. Okay, then we will open the brackets. First of all, we will divide this equality by 2 and we will get that root 2 times 1 minus x squared equals to x. Here we will open the brackets and we will get that root 2 minus root 2 x squared equals to x. So here we will add root 2 x squared to this equality, and we will get that root 2 x squared plus x equals to root 2. So here we will subtract root 2 from this equality and we will get a quadratic equation So we got a quadratic equation. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation and the variable is x. And the solution of this quadratic equation is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, x equals to minus b plus minus root of b squared minus 4 times ac over 2a, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. Okay, so in our specific quadratic equation, the coefficients are a equals to root 2, b equals to 1, and c equals to minus root 2. Okay? So we will use the special formula of x in order to find out the values of x in our specific quadratic equation. So we will get that x equals to minus b. B is 1, so minus b is minus 1, plus minus root of b squared. B is 1, so b squared is also 1, minus 4 times root 2. 4 times a is 4 times root 2, times minus root c, times c, that is minus root 2. All divided by 2a is 2 times root 2. Okay? So we got that x equals to minus 1 plus minus root of 1. Here we have minus and minus is plus, so root 2 times root 2 is 2, and 2 times 4 is 8, and minus is plus, so in total we will get that it is equal to 1 plus 8, that is 9. Okay? So we got that x equals to minus 1 plus minus root 9 over 2 times root 2. The root of 9 is 3, so I write it down. X equals to minus 1 plus minus root of 9 is 3 over 2 times root 2. Okay, so the first solution will be x equals to minus 1 minus 3 over 2 times root 2. That is actually minus 4, minus 1 minus 3 is minus 4 over 2 times root 2, and minus 4 over 2 is minus 2 over root 2. But we know that tangent theta here we have angle theta. This is angle theta. This is 90 degrees. We know we have this right triangle, and here we have angle theta, and actually this is a right angle, and anyway, if you look even in triangle DCE, we have angle of 90 degrees, so if this angle is 90 degrees, then the sum of those two angles will be equal to 90 degrees, so angle theta itself must be less than 90 degrees. So theta is less than 90 degrees. Okay, in our triangles, angle theta, the size of angle theta is less than 90 degrees. Therefore, x that it equals to tangent theta, if theta is less than 90 degrees, then we can deduce that x, that is angle theta, x that is tangent theta, must be greater than 0. It must be a positive number. So therefore, x that equals to tangent theta cannot be negative. X that equals to tangent theta cannot be negative number. Cannot be negative. Okay, x cannot be negative, so this is incorrect answer, because x cannot be negative. X that is tangent theta cannot be negative, because tangent theta, because of the fact that tangent theta is less than 90 degrees, then because of the fact that theta is less than 90 degrees, then tangent theta must be a positive number, therefore it cannot be a negative, so this answer is not correct. So we left only with the second solution that states that x equals to minus 1 plus 3 over 2 times root 2. So minus 1 plus 3 is 2, and 2 over 2 times root 2 equals to 1 over root 2. So we found out that x equals to 1 over root 2, and as you remember, we defined x as tangent theta. So tangent theta equals to x that equals to 1 over root 2. Okay, tangent theta equals to 1 over root 2. Again, we know that r equals to AB times tangent theta. So we finished with the first part of this question, because we found out the value of tangent theta. Tangent theta equals to 1 over root 2, and the only thing that is left is to find out the value of AB. Okay? In the next step we will find out the value of AB. Okay? And as you remember, we also found out that the value of tangents 2 theta is actually equals to 2 times root 2. It equals to 2 times root 2. So we know that tangent theta equals to 1 over root 2, and tangent 2 theta equals to 2 times root 2. Okay? So we will focus on triangle BOE, the right triangle BOE. So in triangle BOE, okay, this triangle, right triangle BOE, we know that tangents 2 theta equals to OE over BO. Okay, in the right triangle BOE, tangents 2 theta equals to OE over BO. But we know that OE is the radius of the semicircle, that is 3 units, over BO. So actually tangents 2 theta equals to 3 over BO. But we have already found out that tangents 2 theta equals to 2 times root 2. So we can substitute tangent to theta by 2 times root 2. We will get that 2 times root 2 equals to 3 over BO. Here we will multiply this equality by BO, and then we will divide it by 2 times root 2, and we will get that BO equals to 3 over 2 times root 2. Okay, the size of BO is 3 over 2 times root 2. You can write here that BO, okay, so BO equals to 3 over 2 times root 2. In the next step, we will join together points O and P by a straight line. So actually AO is tangent to the circle, to the small circle at point A. So we know that tangent and radius are perpendicular to each other. AO is tangent to the small circle, again AO or OA is tangent to the small circle, and AP is the radius of the small circle. AP is the radius of the small circle, and we have the rule that states that a tangent to the circle, radius and tangent to the circle or tangent to the radius are perpendicular to each other. Again, tangent and radius are perpendicular to each other. Again, we have the rule that states that tangent and radius are perpendicular to each other. That is to say, the tangent AO and AP are perpendicular to each other. That is to say, this angle equals to 90 degrees. Okay, angle PAO, according to the rule that is stated, angle PAO equals to 90 degrees. Again, angle PAO equals to 90 degrees. Therefore, triangle APO is a right triangle. Triangle APO is a right triangle. That is to say, we can implement the Pythagorean theorem on the right triangle, triangle APO. And according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square AP square plus AO square must be equal to PO square. Again, in the right triangle, triangle APO, according to the Pythagorean theorem, AP square plus AO square must be equal to PO square. Okay? And we will extend PO until it touches the semicircle at point M. We extend that PO until it touches the semicircle at point M. So actually MP is the radius of the small circle and OM is the radius of the big circle. So actually OM, that is the radius of the big circle, minus MP, that is the radius of the small circle, must be equal to PO. Again, OM, the radius of the big circle, minus MP, that is the radius of the small circle, must be equal to PO, or capital R minus small r must be equal to PO. But we know that capital R equals to 3, so PO actually equals to 3 times the radius of the small circle. Okay, PO equals to 3 minus the radius of the small circle. And what is the value of AP? AP is the radius of the small circle. So AP square is small r square plus AO square equals to PO square, but we have already found out that PO equals to 3 minus small r. So PO square will be equal to 3 minus small r square. Okay, so in total we found out that r square plus AO square equals to 3 minus r square. So here we will open the brackets. We'll get that r square plus AO square equals to 3 minus r square is actually 3 square is 9 plus r square minus 6r. So here we have r square in both sides of the equality, so we can cancel r square. And what is left after we cancelled r square? What is left is AO square equals to 9 minus 6r. AO square equals to 9 minus 6r. Here we will take a root out of this equality and we will get that AO equals to the root of 9 minus 6r. Okay, AO equals to the root of 9 minus 6r, and we have already found out that BO equals to 3 over 2 times root 2. Okay, we have already found out that BO equals to 3 over 2 times root 2. So we have found the values of AO and also the value of BO. And what is the size of AB? AB actually equals, from the drawing you can see that AB equals to AO minus BO. AO minus BO. Again, AB equals to AO minus BO. AB equals to AO minus BO. And we can substitute AO by its value, and we can substitute BO by its value in this equality, and we will get that AB equals to AO is root of 9 minus 6r minus BO. BO is 3 over 2 times root 2. So this is the value of AB, and we have already found out that tangent theta equals to 1 over root 2. Okay? We have already found out that tangent theta equals to 1 over root 2. And we know that the radius of the small circle equals to AB times tangent theta. And we know that tangent theta equals to 1 over root 2, and AB equals to this expression. So in this equality we will substitute AB by this expression, and we will substitute tangent theta by 1 over root 2, and in this way we will find out the value of the radius of the small circle. Okay, so R equals to AB. AB is the root of 9 minus 6r minus 3 over 2 times root 2. That is AB, and tangent theta is 1 over root 2. Okay? So I substituted AB by this expression and tangent theta by 1 over root 2, and we got that R equals to this expression. So here we can multiply this equality by root 2. We will get that root 2 times R equals to 9 minus 6R all in root minus 3 over 2 times root 2. Here we will add to this equality 3 over 2 times root 2, and we will get that 2 times root 2 times R plus 3 over 2 times root 2 equals to the root of 9 minus 6r. Here I will divide root 2r by 2 times root 2, and I will multiply it by 2 times root 2. So I change nothing. So here root 2 times root 2 is 2, and 2 times 2 is 4, so in total we will get that here in the numerator 4r plus 3 equals to the root of 9 minus 6r. Okay. So we got this equality. Here I will square both sides of this equality, and we will get that here we have root and square. The square cancels the root, so we will left only with 9 minus 6r, and here we have 4r plus 3 square. Two times root 2 square is 2 times 2 is 4, and root 2 times root 2 is 2, so 4 times 2 is 8. Okay, so here I will open the brackets. 4r plus 3 square is 16r square plus 9 plus 4 times 3 is 12. 12 times 2 is 24. So 24r over 8 equals to 9 minus 6r. Here we will multiply this equality by 8, and we will get that 6r squared plus 9 plus 24r equals to 8 times 9 is 72. 8 times minus 6 is minus 48r. So here we will add to this equality 48r. We will get that 16r squared plus 9. 48 plus 24 is 72. So in total we got that 16r squared plus 9 plus 72r equals to 72. Here we will subtract 72 from this equality, and we will get that 16r squared plus 72 r minus 63 equals to 0. Here we have a quadratic equation, and the coefficients of this quadratic equation is a equals to 16, b equals to 72, and c equals to minus 63. And the solution for any quadratic equation is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, that is the solution for a quadratic equation. So here the variable x is r, so r equals to minus b, b is 72, so minus b is minus 72, plus minus root of 72 squared minus 4 times 16 is minus 64 times minus 63 over 2a, 2a is 32. So r equals to minus 72 plus minus 72 squared is 5,184 plus minus 64 times minus 63 is 4,032 over 32. Okay, 5,184 plus 4,032 is 9,216. So actually the radius of the small circle equals to minus 72 plus minus root of 9,216 over 32. So r equals to minus 72 plus minus, and the root of 9,216 is 96 over 32. So one solution is that r equals to minus 72 plus 96 over 32. 96 minus 72 is 24 over 38 over 32 is actually 3 over 4, that equals to 0.75. So r, one solution is that r equals to 4, so 3 over 4, that equals to 0.75 units. but we have also the other solution that we must not forget. The second solution for, or the second root of the quadratic equation, that is the second radius of this quadratic equation, is r equals to minus 72 minus 96 over 32. Minus 72 minus 96 is minus 100 68 over 32 equals to minus 5.25. So r equals to minus 5.25, but because of the fact that r is the radius must be a positive number, so this answer is not correct. So we left only with the solution that the radius of the small circle equals to 3 over 4, or 0.75 units. Okay, so the answer to the question is that the radius of this small circle equals to 3 over 4 units, or 0.75 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this small circle. The small circle is inside a quarter circle. We know that angle DCB equals to 90 degrees. We also know that CD equals to 2 units. And we also know that OD equals to 3 units. And we want to find out the radius of this small circle. First of all, we define the center of the small circle as point P. Then we join together by a straight line points A and P, and we join together by a straight line points P and X, and we also join together by a straight line points B and P. Okay. And we defined angle ABP as theta. So we know that tangent theta equals to AP over AB. Okay? Tangent theta equals to AP over AB, but AP is the radius of the small circle, so it is equals to small r. So tangent theta equals to r over AB, or r equals to AB times tangent theta. R, the radius of this small circle, equals to AB times tangent theta. So in order to find out the value of the radius of the small circle, we must find out the value of AB, and we must find out the value of tangent theta. Okay, in the next step I drew again those two triangles. Triangle P triangle PAB and this triangle PAB and triangle PXB. I proved that those two triangles are congruent to each other. Actually, we know that AP equals to PX. Both those two are the radiuses of the small circle, so they are equal to each other. And PB equals to PB, it is a common side, it belongs to triangle PBX and also to triangle PBA. Okay, and also AB equals to BX. AB equals to BX according to two tangents theorem. Two tangents theorem states that the lengths of two tangents from common external point to a circle are equal. So from point B we have two tangents to the small circle. So those two tangents are equal to each other according to two tangents theorem. Therefore AB equals to BX. So we actually proved that all the sides of triangle ABP are congruent to all the sides of triangle PBX. Therefore, we actually proved the triangle ABP is congruent to triangle PBX according to side rule. So from the fact that those two triangles are congruent to each other, we can derive that ABP equals to PBX equals to theta. So those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay? Then actually we extended line segment CB and line segment DO until they intersect at point E, and actually the right angle DCA is a peripheral angle, and we have a rule that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. That is to say, angle DCE, that is a peripheral angle that equals to 90 degrees, according to the rule that I stated, it must rest on the diameter of the quarter circle. That is to say, DE is the diameter of this quarter circle. Okay? And actually this shape is a quarter circle, therefore DO is the radius of the circle, and we know that DE is the diameter of the circle of the quarter circle. Therefore, if DO equals to R, OE must be also equals to R, because DE is the diameter that equal to 2R. So if DO equals to R, OE must be also equals to R, because the diameter equals to 2R. Okay, and we also know that we have a quarter circle, therefore this angle DOB equals to 90 degrees. And we also know that DE is a straight line, as a diameter of the circle is a straight line. Therefore, we have a rule that the sum of the angles on a straight line is equals to 180 degrees. So 90 degrees plus the size of angle EOB must be equal to 180 degrees. Okay, 90 degrees plus the size of angle EOB equals to 180 degrees. So here we will subtract that 90 degrees from this equality, and we got that angle EOB equals to 90 degrees. So this is also a right angle. Okay, and we also have a rule that states that vertex angles are equal to each other. So angle ABC and angle EBO are two vertex angles, and according to the rule that I stated, they are equal to each other. So if angle ABC equals to 2 theta, theta plus theta is 2 theta, then angle EBO must be also equal to 2 theta. So angle EBO equals to 2 theta. And in triangle EBO, this small triangle, we know it is a right triangle, so this angle is 90 degrees. So the other two angles must be also equal to 90 degrees in order to complete the sum of the angles in triangle EBO to 180 degrees. So the size of this angle plus the size of this angle must be equal to 180 degrees. That is to say, angle OEB plus angle OBE must be equal to 90 degrees. But we know that angle OBE, this angle equals to 2 theta. So we can substitute angle OBE by 2 theta. So we got that angle OEB plus 2 theta equals to 90 degrees. We subtracted 2 theta from this equality, and we got that angle OEB equals to 90 degrees minus 2 theta. So this angle size is 90 degrees minus 2 theta. Okay, then we focused on the right triangle, triangle CDE, and we know that the sum of the angles in any triangle, and especially in triangle CDE, equals to 180 degrees. So here angle CDE plus 90 degrees plus 90 degrees minus 2 theta must be equal to 180 degrees. Okay, angle in triangle CDE, the sum of the angles is equal to 180 degrees. So angle CDE plus 90 degrees, angle CDE plus 90 degrees plus this angle that is 90 degrees minus 2 theta must be equal to 180 degrees. Angle CDE plus 90 degrees plus the third angle that equals to 90 degrees minus 2 theta in total must be equal to 180 degrees. So in this side of the equality we have 90 degrees plus 90 degrees is 180 degrees, and on the other side of the equality we also have 180 degrees. So 180 degrees get cancelled because we have 180 degrees in both sides of the equality, and we left only with angle CDE minus 2 theta equals to 0. We added 2 theta to this equality, and we got that the size of angle CDE equals to 2 theta. So this angle CDE equals to 2 theta. Okay, and then we know that triangle CDE is a right triangle because this angle equals to 90 degrees. So we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle. That is to say, CD square plus CE square equals to DE square. We know that CD equals to 2, so CD square is 2 square, 2 square is 4. Plus CE square equals to DE square. DE is the diameter of the semicircle or quarter circle. So we know that r equals to 3. So the diameter equals to 2 times the radius, that is to say it equals to 2 times 3, that is 6 units. So dE equals to 6. And dE squared equals to 6 squared, it's 36. So in total, we got from this equality that CE squared equals to 32. And we take a root from this equality and we got that CE equals to 4 times root 2. Okay, and then in triangle CDE, the right triangle CDE, we know that tangent theta equals to CE over CD. Again, tangent to theta equals to CE over CD. But we have already found out that CE equals to 4 times root 2 and CD equals to 2. It is given us in the question. So tangent theta in total equals to 4 times root 2 over 2. 4 over 2 is 2. So we found out that tangent 2 theta equals to 2 times root 2. Okay? And we have the equality that R equals to AB times tangent theta. So we want to find out the value of tangent theta when we have the value of tangent 2 theta. So in order to find out the value of tangent theta from tangent 2 theta, we will use the trigonometric identity that states that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. So we know that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2 in this trigonometric identity, and we will get that 2 times root 2 equals to 2 times tangent theta over 1 minus tangent square theta. Then we define tangent theta as x. So we substituted tangent theta by x. We got the quadratic equation that root 2x squared plus x minus root 2 equals to 0. And in this quadratic equation, we actually know that the coefficients of this specific quadratic equation is a equals to root 2, b equals to 1, and c equals minus root 2. When the solution, this is the formula for a general quadratic equation, and the solution to this quadratic equation is this solution. So we can substitute a, b, and c by the values that we found out for a, b, and c. So we substituted a, b, and c by the values for a, b, and c, and we found out that x equals to, we have the first solution that is actually negative, but we know that theta is less than 90 degrees, therefore tangent theta must be a positive number, therefore x that equals to tangent theta cannot be negative, so this is wrong answer. So we left only with the positive answer from tangent theta, that is actually x equals to 1 minus 1 plus 3 over 2 times root 2. So x equals to 1 over root 2, and x is tangent theta, so tangent theta equals to 1 over root 2. Okay, so in order to find out the radius of the small circle, the radius of the small circle equals to AB times tangent theta. So we have already found out that tangent theta equals to 1 over root 2, and the only thing that is left to find out in order to find the radius of the small circle is the value of AB. Okay? We know that tangent theta equals to 1 over root 2 and tangent 2 theta equals to 2 times root 2. So in triangle BOE, this triangle, we know that tangent 2 theta equals to OE over BO. Again, tangent 2 theta equals to OE over BO. OE is the radius of the semicircle, it equals to 3 units. And BO is the missing variables. So tangent 2 theta equals to OE over BO. OE is 3 and BO is the missing variable. But we have already found out that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. In total, we get that 2 times root 2 equals to 3 over BO. We multiplied this equality by BO and then we divided it by 2 times root 2 and we found out that BO equals to 3 over 2 times root 2. We found out the value of BO, and then we know that AO is tangent to the small circle at point A. And at point A we have AP, that is the radius of the small circle, and we know that a tangent to a circle and the radius always perpendicular to each other. So the tangent OA is perpendicular to the radius AP, that is to say angle PAO equals to 90 degrees. Okay, angle PAO, according to the rule that I mentioned, equals to 90 degrees because the tangent to the circle is perpendicular to the radius. That is to say this angle PAO equals to 90 degrees. So actually we join together points P and O, and triangle APO is a right triangle because angle PAO is a right angle. So we can implement the Pythagorean theorem in the right triangle, triangle APO. According to the Pythagorean theorem, in the right triangle APO, AP square plus AO square equals to PO square. Okay? And we extended OP until it touches the circle at point M, until it touches the small circle at point M. Actually, the small circle is tangent to the big circle at point M. So, and PM is actually the radius of the small circle, while OM is the radius of the big circle, or is the radius of the big semicircle. So OM equals to capital R and PM equals to small r. Okay, so we know that PO equals to OM minus MP. Okay, PO equals to OM minus MP, and OM equals to capital R and MP equals to small r. So actually PO equals to OM minus MP. OM equals to capital R and MP equals to small r. So PO equals to capital R minus small r. But we know that the radius of the big circle equals to 3 units. So PO equals to R minus R, or capital R equals to 3. So PO equals to 3 minus R. Okay, so in this equality, AP square plus AO square equals to PO square. We know that AP is the radius of the small circle, that is to say it equals to small r. So AP square equals to R, small r square, plus AO square equals to PO square. We have already found out that PO equals to 3 minus R. So BO square is 3 minus R square. Okay, so from this equality we got that OA equals to the root of 9 minus 6R, and we have already found out that BO equals to 3 over 2 times root 2. And what is the size of AB? From the drawing you can see that the size of AB is actually AO minus BO. Again, the size of AB is AO minus BO. Okay, the size of AB is AO minus BO. We found out the value of AO and we found out the value of BO. So we can substitute AO by its value and BO by its value. And we found out that AB equals to this expression. And we have already found out that tangent theta equals to 1 over root 2. So, and we have the equality that states that R equals to AB times tangent theta. We found out that the value of AB is this expression and tangent theta equals to 1 over root 2. So we can substitute AB by this expression and tangent theta by 1 over root 2. Okay, so we did it and we found out that actually we got a quadratic equation. The variable that is missing is r, small r, that is the radius of the small circle. And in this quadratic equation, the solution for this quadratic equation, we have two solutions. The first solution is the radius, is that the radius of the small circle equals to 3 over 4 units or 0.75 units. And we have the other solution that the radius of the small circle equals to minus 5.25 units, but the radius of the circle must be a positive number. So this solution that is a negative one, it is impossible, it is not correct. So we only left with the solution that the radius of the small circle equals to 0.75 units or 3 over 4 units. Okay, so the radius of this small circle equals to 3 over 4 units or 0.75 units. Okay, thank you very much.